theory is that the first feathers in birds were used for insulation, and then later they became more intricate and developed for flight. But the earliest feathers probably looked a lot like fur on this bat, very simple. So mammals use their fur mostly for insulation. And this bat, which is the only truly flying mammal, has solved the problem of flight by stretching a thin, solid layer of skin between its hand bones and its leg bones here. But birds, to have an airfoil that they could move through the air and get lift and really fly, had to develop more intricate structures in their feathers. And if you've ever played with a feather, you can see that they zip. You can tear little pieces of feathers open and they re-zip together almost like Velcro. So this is held together with tiny hooks called barbs and barbules that you can see under a microscope. It's really quite detailed how the feather holds itself together. But then different birds, depending on their lifestyles and what they need to do when they fly, have different shaped wings depending on their ecology. So this wing you see here is from a ruffed grouse. It's quite short and quite fat, so it's adapted to flying through forests. So the bird doesn't want very long wings or it would always be bumping into trees. But the wing is also quite curved, so it's a very nice airfoil that gives the bird a lot of lift. So grouse can hop up in the air and get flying really quickly from the ground. They're not long distance flyers, but their short, stubby, curved wings give them a lot of power for a rapid takeoff. In comparison, here's another wing. This one is from a seabird called a Jaeger. It spends time soaring over the ocean. So it's a fairly open habitat, and it spends many hours flying, so it has a longer, narrower wing. The narrowness means there's less drag, and the smooth and long tapered tips also help it reduce drag and just allow it to soar almost effortlessly on the ocean currents. One of the more highly adapted wings in birds is from a penguin. So penguins have completely lost the ability to fly, and their feathers are modified. They look almost like tiny scales. So they help the penguin be streamlined as it swims through the water. But the feathers are very reduced, and they're just tiny, kind of rough, scale-like vestiges of what a normal bird's wing would look like. And then here we have another large, kind of elliptical shaped wing. This comes from a great gray owl. It's sort of similar to the grouse wing. It's a forest owl, so it doesn't have a long, narrow wing. But what's unique about owls is the soft, furry texture of their feathers that allows them to fly silently. So if you look very carefully, you can see it looks like little fringes on the leading edge of the feathers of an owl's wing that help dampen the sound as the wing moves through the air. And over the surface of the feather, there's a layer of long barbs that looks almost like velvet that also helps dampen the sound. So in comparison to a grouse wing that's very smooth and shiny and makes a lot of noise when the bird flies, an owl's wing is almost completely silent. Birds and mammals have some similarities and some differences. They are both homeotherms, which means you might have heard them being warm-blooded. They can regulate their body temperature. But mammals nurse their young with milk, and birds feed their young through an egg, and later on they have to bring food items to the growing chicks. Many birds also have hollow bones, which is an adaptation that lets them fly. And all birds have feathers, and there is no other group of animals that has feathers other than birds. So that's a unique feature of birds as a group. Some birds choose a quality mate by looking at the brightness of the plumage and how ornamented it is. So one thing they might assess is the different colors. So here you see a blue jay with almost iridescent blue colors that is caused by a structure of the feather itself. So the blue is not a pigment in the feather. It's a structural color caused when the light enters the surface and then refracts off of the feather, giving it the brilliant color. Other kinds of colors birds have do come from pigments. So both red and yellow come from a kind of pigment called carotenoids, which the bird has to eat and then process in its body and lay down in the feathers. So it's thought that carotenoids are a reliable signal of the health of a bird and how well it's been able to forage and eat. So if a female bird sees a bright red male or a bright yellow flicker, it's a good indication he would be a quality mate. Or if the bright blue feathers have grown well during development, they're going to reflect the light really well and also be an honest signal of mate quality. Another weird thing that some birds have is just oddly shaped feathers. Some bird feathers are long, like you might say a peacock's tail is very ornamented with oddly shaped feathers. This is a mallard duck, a very common duck around here, and they have these little curlicues on their tails that have no function apparently except to attract a female.